So in this discussion, I'm going to go over the Lumen method. So the Lumen method is it's used as a way to approximate either the number of luminaires you need, or if you know the number of luminaires and all the other details, you can figure out how bright a surface is going to be, or the illuminance in the room. Okay, so to be clear, there's actually more to it, believe it or not, as I'm about to go over all this. Everything I go over today, which takes a lot longer than you may imagine, actually is not even all of it. So to do full lighting design, there's just so many considerations to make. I think it's a very underappreciated science. And there's some art to it, of course, like when you look at the design, and that's part of the problem. If you're designing a room, you want it to be aesthetic, but you need it to be functional. And the functionality side of things, I mean, the aesthetic, you can sort of figure out, right, for the most part. Now it takes some expertise to do that as well, but the quantification, the amount of brightness that you're going to get from your luminaires, there's just a lot that goes into it. And then when if you have a choice between luminaires and ballast and so forth, there's just really a lot of considerations. So just to be clear, like, this is a little bit of taking a few shortcuts here and there, but it gives you a really good sense of how lighting design is done. And so the Lumen method is something that's used. It's an approximation, so of the number of luminaires, or the number of foot candles you'll get from the luminaires, or the brightness levels. And so we're going to do the former. And so we're going to use it to calculate the number of luminaires to properly light a space. That's what we're trying to get at today. And we're looking at all these different variables like wall color, ceiling color, luminaire type, and some other things. And then how you use the Lumen method to put that all together. Okay, so let's dive in. So first, a quick review of some key terms. We have a lumen, which is the amount of light put out by a lamp. So that's a property of a lamp. The illumination, or the illuminance, is how bright a surface is. Okay, and so we measure that in either foot candles or lux. In the US, we're going to use foot candles. And a foot candle, again, just as a quick review, is how many, how bright, how much light's coming from a candle at 1 foot. So you look at a 1 foot radius. That's where it comes from. Obviously, we're not using candles, so we use that, but that's where this type of measurement started back when they had candles as their main source of illumination. And so a lumen is the unit of light, and then a foot candle is 1 lumen per square foot. So if you take 1 square foot of surface, 1 lumen on that surface, that's a foot candle. So if you have 20 foot candles, that means there's 20 lumens on that each square foot. And then you take however many square feet of surface you have, and that's the total number of lumens you'd have. And so the metric version of that is the lux, which is a lumen per square meter. We're going to use foot candles. Okay. All right. So those that's lumens and illuminance, or illumination, and then efficacy and efficiency. Easy to get these two confused for a variety of reasons. Number one, the words are very similar. But secondly, they're actually, frankly, a little bit confusing in terms of what they mean. So efficacy is what people would normally think of as efficiency. Like, it's the lumens per watt. So it's how many lumens you get per unit of power input of a lamp. So that's a property of a lamp. The efficiency is the property of the fixture, or the luminaire. And so the efficiency is the ratio of light that escapes the luminaire compared to the total lumens emitted by the lamp, or lamps in that luminaire. And so the problem with these fixtures, if you think of a fixture or luminaire, right, like, it's the light for most lamps, really everything but an LED. So an incandescent, a fluorescent tube, metal halide, all of these lamps emit light in all directions, right? That way, that way, that way. I mean, it's all directions, okay? And so the problem is, and some of that light, especially the light that kind of goes that doesn't go directly out, or makes it directly out of the luminaire, like these ones, some of that light can get lost in the luminaire. It can get absorbed, it bounces around, and it just, well, it gets absorbed. And so not all the light generally is going to make it out of the luminaire. And so that's efficiency. The efficiency is the percent of light that makes it out of the luminaire. So just as a quick hypothetical example, if I had lamps or a lamp in a luminaire that are emitting 1,000 lumens, but only 400 lumens are making it out, that's an efficiency of 40%. Okay, so that's how that works. LEDs are pretty much 100% efficient, and everything else really is not. So if we're dealing with fluorescent tubes, for example, which is really common in a commercial setting, we're going to have less than 100% efficiency. Okay, so remember we also have accepted illumination levels, which are brightness levels based on what you're doing. I'm not going to go over every single one here, but basically depending, different tasks require different amounts of light. If I'm doing something that requires really fine motor skills or whatever, I need to see really detailed, like I'm doing drafting, it's going to be brighter. If it's just eating dinner or going to bed, it's going to be dimmer. And remember that IES is the Illumination Engineering Society. It's on the previous slide, Illuminating Engineering Society, and they come up with these standards. Okay, and so you'll see these tables all over the place. Here's just an example of another one, and there's one posted this week. But you can see there's a lot of detail here, and most of these have ranges, right? So let's say we're doing, I don't know, food service. You can see the dining room is 5 to 20. So it depends on some personal preference. Some of it depends on the age of the people that are using it. But those are your illumination levels or luminance levels recommendations. Okay. So let's get to an example of how we use the Lumen method. So let's say I have an office in a commercial building, and I am charged with designing the lighting for it. And it's 50 by 20. Okay, so 50 feet by 20 feet. And I need to know how many luminaires I need to make it adequately lit. And so you want to think about, it's important, do you want a brighter office like this, which is going to be your standard, or something like this, which is going to be a little too dark for most people? Or maybe you want that and you want to add some task lighting. But we're going to use something where it's like kind of a brighter office, a little easier to see. So how do we figure out how many luminaires we need to make a 1,000 square foot office look like that? Okay, so first of all, we need to figure out what our luminance level is. And you look at the IES table, and a general office is going to be 50 to 100 foot candles. So we'll, just for argument's sake, we'll go in the middle there, and we'll say it's going to be 75. Okay, so we need 75 foot candles. That's 1,000 square feet. So how many lumens do we need? Now, if you think about this, remember a lumen is just a foot candle is a lumen per square foot. So we could just do some quick math and say, all right, well, a lumen, we have 1 lumen per square foot. We have 1,000 square feet with 75 lumens per square foot. Some really easy math there. We need 75,000 lumens to light that space. Okay, and so you may think that that's enough. It's not that easy, I'll just say, and that's an understatement. It's not that easy. So we can't just figure out the total lumens emitted, rated lumens emitted by the lamps, and then go from there. There's actually a lot of other considerations. So I want you to think about. So go ahead and press pause and think about what else might impact the brightness levels. Okay, so what might, just to be specific, what might compromise or reduce the number of lumens that actually hit the surface. And if you think about it, there's a lot of things. The wall color, ceiling color, like dark walls versus light walls. The efficiency, obviously, we just talked about, the Luminaire, if not all the lumens are escaping Luminaire. But there's also other things. Dirt and debris build up on the lumen lens. Dirt and debris build up on the, on the lamp lens and the Luminaire lens. There's actually, dirt and debris on the wall, texture of the wall. There's something called a ballast factor. Also, the dimensions of the room is really important. right? So how high is the room? If we have a really, really tall room, really high room versus a short room, all else being equal, less lumens are actually going to make it down to the surface just because of that's how radiation or electromagnetic radiation works. So the further the distance that has to travel, the dimmer it is, or the less lumens you have. So there's a lot to consider. A lot to consider. All right, so let's try to put all this together. And one thing you can do, this is pretty common, commonly used, is called the Lumen Method. Okay, so we have the Lumen Method. So you definitely want to jot down this equation and all these variables. Press pause if you have to. Okay, so the Lumen Method takes there's 6 variables in this equation, right? So there's 5 over here and there's 1 over here. Now just to be clear, this is to determine the number of luminaires required, which is what we're trying to do. The other somewhat common way to use this is if I'm looking for the lumens, all right, so this, this number, the brightness, sorry, the illuminance right here, okay, so that's your illuminance. You can use the equation for that as well. If you know the number of luminaires and all these other factors, you're like, okay, we have 15 luminaires, and here's the dimensions, and etc. How bright is this desk going to be? You can use it for that as well. But we're going to use it to determine the number of luminaires. Okay, and so to be really, really clear about this, this equation is based on an empty room. Okay, so no chairs, no tables, no windows, nothing. Okay, this is just the lights and the walls and the ceiling and the floor. That's really it. Okay, and so just, you know, it's going to be less because there's going to be some absorption with the furniture and so forth. So this is just gives you a good approximation. Okay, and so these variables are, the formula is the number of luminaires, is the foot candles or the illuminance level you want at task height times the area in square feet divided by all of these factors. The total lumen output of the lamp divided by something that's called the light loss factor, and then the coefficient of utilization. Of course, we're going to go over all of these factors here in a minute. Okay. So, first of all, we'll go through this one by one. So we need 75 foot candles at task height. So what is task height? If you remember from the previous lesson, there's different sort of layers of a room. You have your floor cavity, your room cavity, and your ceiling cavity. Okay, so the floor cavity goes from the floor to the task height. Okay, so this is the task height right here, or the working surface. And then we have our room cavity height, which is from the task to the bottom of the lamp or the luminaire. So this cavity can be. It's important to consider the type of luminaire that you're using. We'll get that in a second. So let's say, first of all, the working height or the task height is the height of the surface that must be illuminated. So how high off the ground is whatever you need to be bright, how high is that? So for most people, it's like a desk, right? A table. But maybe it's the floor. If you're doing something that's on the floor, but normally you're going to have something above the floor. And so the default, if you don't know your task height or your working surface height, you just use 2.5 feet. So that's your standard. And that's what we'll use for our calculation. The cavity height, again, is from the task height or the working surface height to the bottom of the lamp. Right? So this comes into play if you have something other than a surface mounted, or other than a recessed lamp, excuse me. So a recessed lamp is going to be flush with the ceiling, but just about everything else is going to be below the ceiling, so you can't just use the ceiling height if that's the case. So if you have something that's suspended or it's a surface mount, it's going to be a little bit less than the ceiling height. But we're going to stick with task height for now because that's what we need. So we're going to assume 2.5 feet. Okay, so we want 75 foot candles at 2.5 feet. All right, there's a good start. So now we have our F1. Our area, that's easy enough, right? So that's just 50 feet times 20 feet, 1,000 square feet. So we have these two factors. Not too bad. Okay, so let's look at the initial lumen output of the luminaire. So in order to do this, we need to figure out what luminaire we're using. We have any number of choices. Now, normally, if you're working for a company, there'll be a designer that sort of says like, well, here's the luminaire we're using, right? So maybe they'll work with a lighting designer that you know, they work with the client and they figure out, you know, what kind of luminaire do they want. Of course, it can be a mixture of luminaires, but in a lot of commercial buildings, you're going to have, you know, usually some overhead, and then maybe you have a little bit of task lighting, but there's different variations. Lighting design is a whole another ball game, and you can do wall sconces, and you can do uplights, and you can, I mean, there's all kinds of different luminaires and applications. So we're going to stick to something really basic, which is what you'll normally see in a standard, you know, commercial building. In this case, we're going to use a recessed luminaire, right? Because this is going to be flush mount, flush with the ceiling. 2x4, really standard. So either generally 2x4 or 2x2. And that's, you know, if you think about, you know, flush mount, you have the ceiling tiles, and the ceiling tiles are 2x4 normally, or 2x2. All right. So in this case, we're going to go with a 2x4. And again, there's all kinds of options for a 2x4. This is what's called a parabolic troffer, and that's where it has these lenses on the front that are sort of like curved. And what it does, it helps get the light out. Like the light sort of bounces out and it comes out. So there's just a straight lens, there's a frosted lens. I mean, there's all kinds of things. But we're going to go with this, which is not uncommon in a commercial building. So this is parabolic troffer. It's 2x4 and it's recessed. Okay, so that's good. Now we need to find the spec sheet, right? And so you can actually, hopefully, you already have, you know, a standard luminaire that you use, and you have the spec sheet already. But if you have to find a spec sheet, it can actually take some time. So let's find that spec sheet. So for this one, this is a sample from the spec sheet. Of course, the spec sheet has more on it, but this is what we need. So you can see there's actually a number of options. We have a luminaire, but like, how many lamps do we want, right? There's different sizes, right? So you can use the same brand and approximate model of the luminaire, right? So there's 2x2 here. Here's a 2x4. And then you have different voltages, which are pretty much going to be the same. The number of ballasts, this is actually fairly important because ballast costs money, and also ballasts are equipment that can fail. So if possible, it's nice to have limited number of ballasts, but there's also other considerations. I mean, everything's complicated, I'm telling you. So we can have multiple ballasts within a single luminaire, right? So if we have like 4 lamps in here and we have 2 ballasts, then that will enable us to turn half the lights on and half the lights off because we have separate ballasts. So a single ballast, it's all or nothing, right? So if all the lamps are connected to one ballast, that means all the lamps are coming on if the ballast is engaged. And you can have multiple ballasts that will then turn, you can sort of do some delamping. But we'll just use something that's fairly standard. We're going to use a 3-lamp luminaire, okay, that's going to use a standard 32-watt T8 lamp. And this way we only have 1 ballast, okay? So we'll use that ballast, or excuse me, that model, okay? All right, so what lamp are we going to use? Again, this is something where you have just so many options for this. There's kind of some standard ones that most companies will use, and if you work for a company, they'll probably just have a standard lamp that they use, you know, or a couple of options. You know, they buy them in bulk and they have a whole bunch of them, and then you just sort of use those unless the client wants something else. So we'll use this one. Let's say our company uses a lot of these. You can see it's a 32-watt T8. And we have lumens here. We have the initial lumen output, 2950, and then the mean lumens is 2830. Right. So of course there's more to the spec sheet, and I have a link here if you're interested in looking it up. And here's, if you remember lumens per watt, it is your what? That's your efficiency. Nope, that's your efficacy. See, I always do that. That's your efficacy. Just kidding. All right, so that's your efficacy, right? Lumens per watt, 92. Nice. That's pretty high for fluorescent. again, everything's complicated. The life of the lamp depends on how many hours on average you use it at a time. So more on and off means less life, right? So here's 3 hours versus 12 hours. Now that is for an instant start. Again, there's different types of ballasts. So you can have an instant start or a programmed start. So a programmed rapid start actually lengthens the life of your lamp. You can see significantly in some cases, right? So 65 versus 36,000 hours for that. Your color temperature is a consideration. This is a 4100K standard for a commercial building. CRI, as you remember, your color rendering index, and that kind of tells you how good it is as rendering color. So again, there's all kinds of considerations. There's sort of some standard options, and this is pretty standard, right? So 4100K T8 32 watt 4-put fluorescent tube. So we'll go with that one. All right. So now we have our lumens, and we're going to use the initial lumens, to be clear. All right. So remember, we have to go back to the Luminaire, right? We have 3 lamps. They're 2950 initial lumens per lamp times 3, so 8850 lumens. All right. So that is our initial lumen output. Okay. So like I said, it's not quite as easy as just picking a lamp and multiplying it by times the number of lamps per lumen. Okay, so now we have the first 3 factors. So let's look at our light loss factor. Okay, so this is another one of those that we're only taking a few of these variables. You could take more. There's more to, just put it this way, there's more to consider than the ones we're going to do. So, light loss factor. There's actually an adjustment to the luminance based on like what's actually going on in the field. So there are certain things that reduce how much light actually hits your working surface. So there's something called lamp lumen depreciation, or LLD. So that is, over time, lamps put out less light. Okay, and so it's nice. Initially, it's going to be brighter, and it's just not going to be bright. It's not going to take that long to be dimmer, and it's just lamps. They lose their light over time. It's just the property of the lamp. We have luminaire dirt depreciation, which is LDD, and that is just dirt and dust getting on the lens and the luminaire. Right. Again, this is what happens in the real world. We have things like lamp burnout factor, and there's actually some other ones that you can consider, but we'll stick to the main ones. These are the primary ones that we use, are LLD and LDD. And then those are all what are called recoverable factors, which means you can fix them, basically. So non-recoverable are things that you can't fix with the lamp, and that's things like a ballast factor. So ballast, depending on the ballast you use, you actually get usually less lumens out of the ballast than the rated. Sometimes you get more, but usually it's less. And then there's like the ambient temperature that it operates under. Again, that's not a property of the lamp. That's something that's not within that area of control. And so those are non-recoverable factors. Those are ones that are not lamp-based. And there's more than this as well. So we'll stick to the main ones, which is lamp lumen depreciation, lamp dirt depreciation, and then ballast factor. To calculate the light loss factor, getting back to what we're trying to do here, the light loss factor is just a product of all of these. And these are almost always going to be less than 1. And so you're going to multiply this decimal by this decimal by this decimal, and so on and so on and so on. And you multiply all that, and that's your total lamp loss factor. Okay, so we'll stick to these 3, as I said. So we'll start with lamp lumen depreciation, or LLD. So LLD, again, is the light output diminishes over time, right? And so there are different charts out there. This is one from the U.S. Department of Energy. And so this is a good source, obviously. And so this shows you different types of lamps. We have a T8, we have a T12, we have a high pressure sodium, and so on. Okay, so if you look at the fluorescent, which is what we're using, a T8 4-foot fluorescent. You can see that after 9,000 hours, it's going to be at about, we'll call it like around 95%. Okay, so the standard for the LLD is how much light, what percent of light is it putting out when it's at 40% of its rated life, or when 40% has passed, right? So if it's, let's say it's a 10,000 hour rated life, so what's after 4,000 hours, what's the light output going to be? And these are just, I mean, again, this is one of those things where you just sort of have a choice, but that's the standard, is to use the 40%. Some people use 50%. I've even seen 30%, but we're going to stick to 40, and it's going to be, for ours, it's going to be a 0.95, right? So 0.95. All right. So that's LLD. So now lamp luminaire dirt depreciation, or LDD. Again, it's complicated. It depends on the type of luminaire you have, right? So we have all these different types of luminaires. I'm not going to go into detail. Feel free to press pause, but this is based on what the luminaire properties. And so for here we have the top enclosure, remember, is opaque, right? So it's solid metal up there. And then the bottom enclosure, we have louvers. All right. And so we are a category 4 luminaire. And so now we look at the IE, the luminaire dirt depreciation based on the category. So we're category 4 here. We look at this table. Now we have options here. We can do very clean, clean, medium, dirty, or very dirty. And you notice the very dirty, there's a big drop in output. Then we have less and less and less the cleaner it is. But even very clean, you're going to have some depreciation. Like, it's just, you can't prevent it. Dirt and dust is going to get on that lens and the lamp. So we're going to go with clean. That's sort of like right in the middle. And remember, we're a category 4. So here's our clean line. The standard here is after 18 months. So we'll go to 18 months. And on the clean line, we're at about 0.85, we'll call it. Okay, so that's pretty normal. LDD of 0.85 is pretty normal. Okay, so that's our LLD and LDD, or lamp lumen depreciation and lamp dirt depreciation. So finally, we're going to do our ballast factor. A ballast factor is a property of, excuse me, the ballast in the lamps. And so remember, all fluorescents need a ballast to operate. Almost all ballasts are going to decrease the wattage. Maybe we haven't gone over this, so we'll take a quick step back. All fluorescent lamps need a ballast to operate. So a ballast is going to normally look like this, and you have these wires coming out, and those are connected to the lamps, and they will they sort of do things like they regulate the voltage and the current and all that sort of thing. And so the electricity runs through this before it goes into the lamp, right? So it regulates that electric current and voltage. And so they need these to operate. And one of the issues is that they usually decrease the lumens that come out of the lamp. So the lamp is rated a certain lumens, and this is going to usually drop that. And it also drops the wattage that goes into it. And so usually it's going to be less than 1. Okay, so usually the ballast factor is going to be less than 1. It all depends on the lamp used and the type of ballast you use and so forth. And just to be clear, some ballasts do increase. They have a ballast factor greater than 1. T5s, the really skinny fluorescent tubes, they often have a ballast factor greater than 1. But normally it's going to be less than 1. Usually it's around 0.86, 0.88, something like that. Ideally, what you want to do is find the spec sheet of the ballast, match it up with your lamp, and then you can figure out the ballast factor. And just so you know, if you're dealing with LEDs, they don't use a ballast, they use a driver. Ballast factor of 1. CFLs, incandescent, ballast factor of 1. So you don't have to worry about ballast factor for those. So normally we want to try to find a spec sheet. So let's do that. So this is the I looked up a ballast, and to make sure it's compatible. It actually takes a little bit, sometimes a lot, of investigation to find a ballast that's compatible with your lamp. And so I did find one. What I did for this is I went to a vendor just online, found my lamp, and a lot of times they'll say it's compatible with this ballast or this and this and this, right? And so I found that, and here's part of the spec sheet from that ballast. Okay, so you can see we have all different types of lamps. F32, that's 32 watt. This is a 28 watt. This is a 25 watt. This is a 17 watt. And then, you know, the number of lamps is a consideration, right? And so remember, we have an F32 T8, and we have 3 lamps. Now the voltage is important too. We'll just assume we have 277 volts. And so based on that, our ballast factor, right? So you look at the ballast factor column here, and so our ballast factor is going to be 0.88. Okay, so ballast factor of 0.88. All right, so now we have those 3 variables. We have our lumen lamp lumen depreciation, lamp dirt depreciation, and then our ballast factor. You multiply those 3 together, and you get 0.71. Okay, so that's our light loss factor. It's 0.71. Okay, finally, let's get to the coefficient of utilization. All right, so CU, or coefficient of utilization, this is the percent of lumens that make it to the working surface. This is a property of the luminaire. Okay, so it's a property of the luminaire, not the lamp per se, although the lamp does impact this if it's an LED. So you can have LED tubes that basically are going to have a CU of 1, but everything else is going to be a CU less than 1. And so this all depends on things like the wall color, ceiling color, and the floor color, and the room dimensions. Okay, and it's a property of the luminaire. So we'll go over this. It's a lot easier just to go over an example. So what do we need to do this? We need the luminaire specs. That's absolutely essential. And then we need the room height, width, and length, including all of the different, the working surfaces and so forth, and then the wall, ceiling, sometimes the floor color, but really the wall and ceiling is what we need. All right, so we go to our parabolic troffer that we have. Remember, this is our luminaire. Here is a snip from the spec sheet, which is available here if you want to look at it. And so what do we need? We need this. These are the coefficients of utilization here. So this is a CU table or a photometric table. Okay, and so all of these numbers are CU, and these are actually percentages. Okay, so CU is right here, and so in order to do that, we need this is the floor, ceiling, and wall reflectance, which is based on the color, and then we need the room cavity ratio, which is based on length, width, and height. Okay, so remember, we need all those things. So how do we do this? So let's start with the RCR, the room cavity ratio. So the room cavity ratio is based on this formula. It's 5 times the cavity height, and then you multiply that times the length plus the width. That's a plus, and then divide that by the length times the width. Right. So that's our cavity height. So what is our cavity height? So be careful, because our cavity height is just between the working surface here. In this case, it would be here where the luminaires are. In our case, we're at the ceiling, right, because they're flush mount. But it's going to be, that's your cavity, your room cavity, excuse me. All right, so let's say we have 9.5 foot ceilings. It's a recessed light, it's flush mount. Remember, our working surface is 2.5 feet, going back to our earlier. So it's 9.5 feet is the height minus 2.5, our working height, and that's going to be 7 feet. All right. So 7 feet is our cavity height, and then we know the length and width already, which is 20 by 50. So we plug it in, and we get 2.45. Okay, easy math once you can figure it out. All right, so that's our RCR is 2.45. So remember that. So now we need our ceiling and wall reflectance. The floor, sure, but normally floor is, we just make an assumption. There's all kinds of tables out there, so you got to be, just find a good source. And hopefully your wall and ceiling color are on there. That's the best advice I can give you. It's actually really hard to find this sometimes. So if you don't know any of this, you can use a default of 80-50-20. 80% ceiling, 50% wall, 20% floor. Okay, but we do, let's say we have an off-white wall, you know, and then a beige ceiling. Okay, we'll just say that's what we have. It's nice to have a light color. Obviously, the lighter it is, the more you're going to reflect. Okay, and then the floor we're just going to say is 20%, right? So we have 70, 50, 20. Okay, so 70, 50, 20. Ceiling, wall, floor. All right, so let's look at 70, 50, 20 on our CU table. So you can see here, here's your floor reflectance, 20%, ceiling reflectance, 70, wall is 50. And then remember our RCR is 2.45. We're just going to round that to 2.5. That's fine. So it's halfway between here, and then we're going to use these numbers. Okay, so we're using these numbers. And if we do that, here's what we end up with. Okay, so remember 20, 50, 70. And so we're halfway between 70 and 62. So just shoot the middle. It's going to be 66. Okay, so 66% is our CU, or coefficient of utilization. Okay, so remember you have to find the spec sheet of your Luminaire to get this. Okay, that's where you find this. Again, if you don't have any of this, you don't have a Luminaire spec sheet, it happens, right? You can't find the Luminaire spec sheet. You just go with 20, 80, 50, 20. You would go with these numbers, which you can see is not, it's going to be a difference of 1%. Not a big deal. All right. Okay, so now we have all our numbers. We have 0.66 for our CU, right? So we have everything. So let's plug them in. So how many luminaires do we need required? Let's plug and play. We have everything. Plug them in. You get 18. 18.08, which we can say is 18. That's fine. Again, this is an approximation. All right, so we need 18 luminaires. Now remember, this is an empty room and so forth. But 18 it gives you a good idea, and you're going to be fine with 18 if you do that. Unless you have like a whole bunch of really dark furniture or something, you should be all right with 18. And if you maybe you do add some furniture, you can add some accent lighting, task lighting, whatever. Right, so we need 18. So think about like if we didn't do the Lumen method, didn't use the Lumen method, and we just did that simple way that we started with at the beginning, where we just take the area and the desired luminance levels, and remember the initial thing that we did. We figured out we needed 7,000. I think it was 7,500 lumens, and then if we take the lumens per luminaire based on the initial lumens, right? Like there's 3 lamps and there's whatever it was, 29, 40, 50 lumens per lamp, and we divided it by that. So remember, like the total lumens divided by the lumens per lamp, and we're going to get the number of lumen or number of lamps. So if we do that and ignore the light loss factors and the CU, all of these which reduce the effectiveness of the lamps, we would assume that we only need 8.5. 8.5, right? We're ignoring the light loss factors and the CU. That's a big, big difference, right? Like that room is not going to be bright enough. And then let's say that's with our initial lumens. Let's say we do mean lumens, right? Which is from the specs of the lamps. Even with mean lumens, we're going to assume we only need like 9 of these, which is exactly half of what we actually need. So the point is, it's really important to consider these other factors. And they can obviously really reduce the effective illuminance, or the effective lumens, if you will, of the lamps in the fixtures. So really, really important to consider all of this. And I know this was like a long video and this was a long process, but that actually is, I took some shortcuts there, I made some assumptions, and if you had any idea how much time it took me to figure out all of those, it takes a long, long time. So, or it can take a long time, let's put it that way, to find like all these spec sheets and all that sort of thing. And so just so you know, this is a really in-depth process. It takes expertise to do. And so this just kind of gives you like an idea of what you would do. All right, a good idea, but an idea nonetheless. All right, so we need 18 fixtures. All right, so the last thing we want to do is figure out how we're going to arrange these luminaires or these fixtures, right? So what you should have is ideally they should be spaced evenly, right? Obviously you want everything to be symmetrical, so you don't have bright and dark spots. And the rule of thumb is the distance between the luminaires should be equal to the length or the width of the luminaire. And I'll show you this example here in a second. And then the distance from the wall should be half of the luminaire length or width. So we have 18 fixtures, so this works out pretty nicely for us. We can have, 6 rows of 3, 3 rows of 6, whatever. This is our room. Remember, it's 50 by 20, and our luminaires are 4 by 2. So we need 18 of them. So if we want them spaced evenly, we can do something like this, right? So remember, this is 4 feet this way and 2 feet this way. And so we want to have 4 feet between them in this direction. And we have 2 feet between them in this direction. And then between the wall, we want half of 2, which is 1, and half of 4, which is 2. Right? So this is pretty ideal. It doesn't always work out this way, but in this case it does. So that's how you really, that's an ideal arrangement. 4 feet wide and 4 feet between luminaires. 2 feet, or I guess 4 feet long, so 4 feet between. 2 feet wide, and we want 2 feet between the luminaires, and then we want half of that next to the wall. Okay, so that's a pretty perfect arrangement, right? So that is going to be our design for this example, right? So again, back to the beginning, we have the how many fixtures, how many luminaires do we need for our office to give us 75-foot candles? We're going to need about 18 of them. And in an ideal world, they would look like this. Now, you can play around with this arrangement. Maybe we could flip these the other direction, but in this case, it works out really perfectly. Okay, so I apologize for the really long lesson, but hopefully you have a good sense now of how we can determine the number of luminaires to provide adequate light to space and consider all these things like wall color, ceiling color, ballast factor, light loss factors, and so forth, right? And so we use the Lumen method to do that. And again, if you already have the lights in the room, you have the fixtures, you have the lamps, you have the ballast are already there, and you're doing like an audit, for example, and you go to a room, you can actually, find all the spec sheets for everything, and then you can calculate how bright it should be at the surface. Okay? All right. So thanks for sticking with me. Hopefully you made it through the whole thing, and hopefully you have a better sense of how to use the Lumen method now.